Let's get going. Good morning. My name is Ben Drücker. I want to talk about the 3 common pitfalls in microservice integration. And actually, that was the QCon shortened the title to fit on the printout. So it was actually and how to avoid them. So I will also talk about how to avoid them, not only about the pitfalls. I'm Ben Drücker. I'm the co-founder and developer advocate of Camunda. We're a company based in Germany. We're doing open source workflow automation. I've written a lovely book about BPMN. I talk about that later on a bit. And we will run short in time at the very end. So if you have any questions, we have a booth downstairs, or feel free to drop me an email, to tweet me, to ask me anything you want to. So basically, I use microservices in the title, but we are basically want to talk about distributed systems. So who in the audience has at least one like REST call, SOAP call, something with a cloud, SaaS, whatever it is, something remote in the architecture? Here we are. So this is what we want to talk about. And I like this metaphor actually very much for distributed systems. So whenever you're there in that small hut, that's your application, that's your one service you build. That's a really lovely place to be there. You have transaction management, it's warm, you have a heating, you can code in one language, so it's pretty great to be there. But whenever you open the door, you basically face the network, and the network is this rough ocean, so a lot of things will fail there. I don't have to dive into that too much. I think you should be all aware of the fallacies of distributed computing and all the challenges you will have out there. And that's what we want to talk about. And I basically have in my slides 3 challenges. So communication, basically, how to communicate between microservices, synchronously and asynchronously. And then the third one, and that's actually my favorite, we will do that at the very end. It's about distributed transactions, how to guarantee certain consistencies in these kind of architectures. I also wrote about it, so if you prefer to read it afterwards, there's an article on InfoWorld. It's not on InfoQ, sorry for that, but it's pretty good anyway. So that's a reference there. So let's assume you have a couple of services, like whatever it is, like many of them typically. So what we start to accept is that we accept failure in at least one of these services. So it might be the service breaks down, the service, you have a network problem, a partitioning, you cannot reach the service anymore. So you will have some failure sooner or later. The thing is, the important thing now is that you basically avoid that this failure really brings down the whole system, that you really, it goes to all the services and brings down the whole system. So this is what we still see a lot out there. And they're basically easy strategies to handle that. And I want to do that by using a simple example, a very simple example actually, but it's enough to show most of the things. So let's assume you build a payment service. And actually a payment service could be like 10 services or 100 services on its own. If you really are into payment, you know that. But I make a very simple payment service. And then I use an upstream credit card service to actually do the credit card handling. You probably will not do that yourself. And I will show code actually, because I want to dive into that a bit more. In this case, I use Java and Spring Boot. Who's using Java here? Okay. Oh, that's even the majority. So anybody using .NET? Go? Python? Okay. PHP? No. Oh, nobody. Oh. Okay, but I use Java for now. But then this is great. So let's jump into the code actually right away. So the first thing should be actually very familiar to basically everybody. So I use Spring Boot or Spring. So I basically have a REST controller which provides a method, like I can do payment. This is in this case a put method. I provide some data, which is not that important here at the moment. And then what I actually do is I charge the credit card. And how do I do that? I want to call an upstream REST service. So what I could do, I could use the REST template because it's Spring. So I create a request object, and then I use the REST template. I do a post for this URL with the request object. I get a response back, and that's it. Very easy to understand, I think. That's actually not the goal of my talk, to explain that. Who has done something similar in his code as well? Okay, most of you. Okay, then you know what I'm talking about. So I have these guys running. So this is the payment service in Spring Boot, and this is the upstream Stripe service. And then I can use Postman actually to do a request. So let's do a request. I get a response back. In the background, the Stripe service was called. That's not very surprising, actually, but it's good to know that this works. The next thing, I can make the service slow. I mean, it could shut it down, then this one would not work. I think that's very easy to catch. What happens if the service, the upstream service is slow? That's a test question if you mastered the pub crawl yesterday. It's an easy question. What happens if the upstream service is slow? Yeah, exactly, very easy. The payment service is also slow. So this is loading, 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 because I'm blocking the request with the call, the synchronous call to the upstream service. That's actually very easy to get. Why is this a problem? And that's more interesting actually to look at. So in typical architectures, this gets a problem very fast because now you're having a thread pool at the payment service. These threads are all blocked by waiting for the upstream credit card service. And that means after some time, your payment service cannot serve any requests anymore. So that's actually pretty bad to do. And there are a lot of scenarios around that which you construct which are really bad for that overall architecture. So that's what I meant with burning down the whole system by just one slow service. And so this is something you want to avoid. And then there's an easy workaround for that. Who knows the circuit breaker pattern? It gets less and less hands, but it's 50% maybe. So the circuit breaker pattern, it got very famous by Netflix. There's an implementation called Hystrix. That's what I use here as well. And the circuit breaker does basically what the circuit breaker in your house does. If something is strange with the electricity before the house burns down, it just stops everything. So the electricity is turned off until you turn it back to normal. And that's basically the same thing. So the code actually, and that's interesting, I actually have prepared it to save a bit of time. But the only code change I had to do in the simplest case is this line. So I have still my REST request, but I nested into a command, a Hystrix command, and now Hystrix does the real execution, and it takes track of the timeout. And then it can basically switch off the circuit breaker, and depending on the configuration, if you have a faulty service, you might not even call it anymore because it's switched off, and then you can immediately fail. So if I use that version, it changes. So the behavior changes. So my upstream service is still slow. I do it again. And now I get the Hystrix timeout. Depending on the configuration, this might be, I think in this case, it's 1 second. I configured it to be 1 second. But this depends on your requirements. So this is a very important basic pattern you actually should know about. So if you're doing REST requests, you should know that circuit breaker thing. But it's very easy to get information about that. So this is pretty well known. If you're looking at, for example, currently service mesh is quite hip issue and these kind of things, they're also having a circuit breaker on board. So that basically guards basics of your synchronous communication. So this is important. I mean, that's very important. I have another example in a minute. But from my experience, it's not enough. And that's what a lot of people currently miss. And I want to give you an example. Who has used an airplane before? Most of you, okay. That's great because then you're familiar with the process. So you're booking your flight, and then you have booked the flight, and like 1 or 2 or 3 days, depending on the airline, before the flight, you get an invitation to check in. Then you click on the link, then you select the seat, you select something else, you confirm that you don't bring dangerous goods with you, and then you're checked in, and then you have a button where you say, give me my boarding pass, right? That's an important button. It's an important step in that process. And it was actually great when I prepared a talk last year. Also in London, I flew to London, and then I did all that, and when I clicked that button, I got that error message. It's in German, sorry. I flew from Germany to London, but it basically said there was an error while sending you your boarding pass. So how I envisioned it in the background was something like, okay, I had that check-in thing, but that obviously doesn't do the boarding pass. So I think there were other components like creating a PDF if I want to print it out, or generating that 3D barcode, which is quite an important thing. And my experience from a lot of customers, actually, if you walk in a meeting and say something like output management, everybody goes like, ooh, that's kind of a tricky thing that always fails. We can only do like 1 PDF at a time and these kind of things. So that's probably a good source for errors. So I expect something to happen there, which is, I mean, it's okay. Again, distributed system, some things might fail. And they did some homework. So I think they had something in place to avoid that, to bring down the whole website, which is actually not like normal. I had a flight last week from New York back, And I got this from United Airlines. So this is when I clicked exactly the same button. By the way, I have a collection of like 10 airlines doing these kind of things. So it's a pretty common problem. But I started collecting them. So all the time it happens to me now. I'm kind of happy that this happens. But anyhow, so I got this. So they didn't. So that's even worse. But the bad part is still they have that fail fast thing, and they transport the error back to me, in this case to the user. I mean, why should I care if they can generate the barcode? Why is it my problem? What can I do about it? And actually, if I have smaller audiences, I typically ask, and there are 3 default answers to that. The first is, it's kind of the end user answer. The normal folks says, oh, I would print out the page. Okay, great, I bring the error message to the airport. Don't know if that works. Then there's a second answer, it's kind of the management answer. Oh, I would call the airline, I would escalate it, I would do something. So that's probably that brings me further. What's the programming answer to that? The programmer's answer? Retry, try again, exactly. So I tried again immediately, it didn't work. I tried again like a couple of minutes later, it didn't work. I made me an appointment in my calendar to not forget to retry it in like a couple of hours. And that's what I did, and it did work. It did work. But I had to do something I call the stateful retry. So I have to do the retry. It's not like I do it immediately. I have to remember that, and I have to do it. And it's actually, why is that my problem? It shouldn't be my problem. The funny part of that story, and I promise that's really true, my flight back from London was with EasyJet. And that's awesome actually, they had the same problem, and they gave me the work instructions. And that's really awesome. So we're having some technical difficulties. Please log on again, retry. If that doesn't work, please try again in 5 minutes. Okay, increase the interval. And the best thing, we do actively monitor our site. We'll be working. There's no need to call. It's your problem, don't bother me. It's your problem, you have to resolve that. That's bad design. And it's not only if you're user-facing you get these kind of problems. I mean, you can have the same problem if you have service-to-service calls in your own network. It means that your client, might be another service, automated, has to care about these things. That's pretty bad. It would be much better if they say something like, okay, we have a technical glitch, but don't worry, we have your email address, we have your mobile number, we send it whenever we can. Don't worry, you will get it on time. That would be perfectly fine for me if they send it later on. And that's one of the things we have to talk about. And the same thing, so the check-ins should do the stateful retry, and that would mean that the error resolving part, the failure resolving part, would be much more local in your architecture. So you don't send that error to a lot of components, but you can resolve it where it actually occurs. The thing, or from my experience, why people don't do this kind of thing is actually there's something like stateful retry. Though that means I have to handle state somehow, which is actually, I mean, we have 2018. It should not be so hard to handle state, but it turns out it is. So what's the naive approach of handling state? You do what I call a persistent thing, which is most of the time an entity, like a table, database table, very easy to do, or probably a document, or if you're more fancy, it could be a persistent actor. So there are a couple of things you could do in order to make something persistent. But the thing is, you have to do it on your own. And remember, you have to do that retrying, for example. That means you have to have a scheduler. You probably have a lot of boarding passes to send, so you probably need some kind of operating tool to see through that, and these kind of things. So a lot of people, I think, internally somehow sense that this is kind of slippery ground, so they back away from that because they say, okay, that gets a lot of effort, just rethrow the error. That's easy at the moment. And that's kind of a problem. And it's actually true if you go down that route, and that the other part, what I see like once a month, if the people build that themselves, it's a lot of accidental complexity what you get there. So you might think about scheduling. Versioning, it's a great thing. So if you have like these long-running things like retrying for hours and you change the behavior in the meanwhile, you have to think about running things there. So it's not easy to do. And doing that at scale also is not very easy to do. So that's an interesting part. And there's actually a second thing, and that's what we are working with a lot, which seems to be quite forgotten or has a bad reputation out there, which is normally a workflow engine, which is in its back. It's basically a state machine, which can handle that state. And there are a lot of, again, concerns why people are not using it because they consider it as a very proprietary, heavyweight thing. which is kind of slow, maybe not scalable, and they made the experience with basically big vendors in the ancient times of SOA and BPM, like you remember, like 5 years ago. So, where the big suites were sold, which are really not great for the developers. But the thing is that this is not necessarily true. So there are a lot of tools out there which are going down a pretty different route. And if you look at the market for workflow engines and state machines at the moment, it's pretty interesting because there are a lot of things going on. So if you look at the serverless things, serverless architectures, for example, AWS, they have something called step functions. So that's to orchestrate functions. It's a state machine. And all the other cloud vendors are at least thinking in these kind of directions as well. If you look at Silicon Valley, you see new frameworks emerging, like all of them last 1 or 2 years ago, like Uber did something with Cadence and Netflix did something with Conductor. They are very much into their universe. So Uber is Cassandra and Go only, and Conductor needs to run Dynamite DB. So there's kind of, if you're in their universe, it's okay, but for normal folks, it's kind of hard to use. But there are quite a lot of what I would call lightweight open source engines available, especially in the Java space. So much people showed up with Java, so there are a couple of them which are really great. Also at scale, so this is a project we're currently doing as an open source project. There we can run basically the same amount of events per second as Kafka. So we can really scale out to millions of workflow instances a second. So it's not limited in scale what you can do. And for today's demo, I use the Camunda engine. That's by coincidence the one from the company I co-founded. So that's probably a bit opinionated, but it's pretty comparable to a couple of these others. So for me, for the moment, the important part is the concept. But I want to show you one with code examples to actually make it very concrete. What I mean also by lightweight engine, because that's kind of a fuzzy term. So let's get back to the Eclipse. And we will run the same example actually, but this time I added a couple of things. And again, we're in Spring Boot here, so it would look a bit different in different architectures, but that's Spring Boot. Because it's Spring Boot, we have a Spring Boot starter, the engine can be very easily configured, and then I just auto-wire it here, or if I'm using Spring Boot stuff, and I might not even auto-wire it, but I just get it injected. And then what I can do, whenever that bean is created, I create a flow definition. And what we use internally for that workflow definition is called BPMN. It's an ISO standard. I come back to that in a second. But it's from the language, I think it's really awesome. It's still pretty great. So I can create an executable process. I start it. Then I have a service task. So it means I basically invoke some code here. And what you can see is that we just attach, in this case, a Spring Bean to be executed. So very easy. It doesn't have to be a Spring Bean. There are multiple ways, but that's what we're doing here in Spring Boot. And then I have the end event, and then I'm done to define that. And now I have, so far it's probably not that awesome, but what you have now is a state machine in the background. So you can do things like, okay, the naming is probably not the best, but do a job retry time cycle. So that means retry it 3 times with a delay of period time 1 minute. This is how you can read that. So you configure that retry, and it could be like running for days. And running, by the way, is misleading. It doesn't run, it means it waits. And I mean, workflow engines are great at waiting, not at running. So they are waiting, and that means the state is persistent in the database, and we keep track of the scheduling stuff and this kind of. And the next thing you can do is you deploy that flow to the engine. It keeps track of versioning and all these kind of nasty details. This code I referenced here, by the way, is the code we already know. So this hasn't changed at all from the last version. It's still the REST template post request guarded by Hystrix, so that hasn't changed at all. And then the only thing I do whenever I charge a credit card, I don't do the REST request directly, but I start a process instance. And that's it. That's the only code changes. Code is on GitHub, so you can check it later on in all details. You can run it. You can play around with that. So what you can see is that it's very easy code. And now the behavior changes again. So this is version 3. So if I call version 3, and let's open the Stripe service, it's still slow. So whenever I do that request, it will be slow. So Hystrix will guard that. And what I get, by the way, now is here. You see I don't get a failure message anymore, but I get a 202 accepted. So that means, okay, we got the request, we will do whatever we can. It will not work though, because the upstream service is still slow, it's not working correctly. So what happens, let's quickly look at that, and that's what all these kind of tools normally have. In the details it might be pretty different, but the idea is more or less the same. So you can look into the engine. I mean, it's a workflow engine, it's state, we can look into that. So we can look at that version 3 process. We can see how I defined it. You see, that's the flow I created with these 3 lines of Java. We generated a graphical image out of that in BPMN. We see there's one guy waiting, and this still does the retry in the background. So that's what I mean by the state machine. It's now there. Now you could, so a typical question would be something like, okay, but now you have that 202 accepted. That's great. You do it in the background. Okay, understood. That's kind of an asynchronous way of handling these kind of things, but I want to have a synchronous answer here whenever possible. So in this case, it's not possible because the upstream service is not available, but we can make it available, which is, for me, it's very easy to just fix it. So it's back to normal, awesome. So I can do it again, and I still get that 202 accepted. And this is sometimes a behavior you don't want to. You don't want to be forced to move to an asynchronous behavior. And the awesome thing is that you're not forced to. I mean, I don't want to dive into that code anymore. 3 lines of code on 2 places. You can look it up on GitHub. You can very easily make that synchronous again. But it's not really like a synchronous blocking call, but it's executing. And it basically has configured a timeout where it waits if that workflow instance completes within that timeout. And then you can do very easily synchronous responses. So this time, probably not visible from the back rows, so it's a 200 OK. So I get back my result. So whenever I do that, everything works smoothly. I get a 200 OK. It gets slow. I get a 202, and I get a callback later on. So this is how we can use these kind of things. And that's actually pretty awesome. So this, now you have this kind of a state machine in there. One important thought, whenever I say workflow engine, a lot of people actually envision it in a way that there's some central workflow engine somewhere running, somewhere. But it doesn't have to be that way. I see it, especially if I'm talking about microservice architectures, very much being part of the service. So it can run embedded in the payment service. That's what I do here with Spring Boot. And then this is responsible of keeping the state, right? Yeah. So I think one of the key points in distributed architectures, distributed systems, is also to have this kind of retry, but also having a stateful retry, not for all the requirements, but for some of them. One important thing, and I don't dive into details of that much, is that the service provider also have to provide idempotency. And that's one of the key things you have to remember, I think, in distributed architectures at all. That's a key thing. You should always make your services idempotent. It makes life so much easier. I have an example for that. It's again an end-user use case because it's normally easier to imagine these kind of things. Have you ever paid with a credit card on the web? Yeah. Do you remember the ancient times? It doesn't happen that often anymore. But do you remember these loading buttons where you say, okay, you entered your card and then it loads and loads and loads and we're processing your payment. Do not reload that page. I'm traveling a lot. I use these pages in the train. There's a really leaky Wi-Fi connection. So that makes my heart beat. It's like, oh, well, what do I lose the connection? What will happen? Do I reload and do the payment twice or whatever? That's a really bad design. You should have something like there's a payment or a correlation ID. You pass it on with every call and you detect duplicates. That's so important. It's so important. You should do it anyway, everywhere possible. So the same thing could be much better. We are currently processing your request. Awesome. Don't worry. It will happen safely. You can do whatever you want. Great. This is how it should be. And the same for service-to-service communication. And one tiny detail, sometimes people spot that and ask that. I'm not sure if somebody spotted that. That would be great, actually. Then you're deep into these kind of things. I did a retry on the charged credit card. Histrix said, oh, that takes too long. I just cut off. I have a failure. Probably I retry that a couple of times, and then I say, and this is possible in BPMN, for example here, to say the retries are over, no more retries, so I do a plan B, like whatever. In this case, payment failed, or I could use a different payment provider, whatever it is, so I can do something else. That's great, it's a fallback. But remember, distributed systems, you have that ocean, you have the problem that you cannot differentiate basically the three failure scenarios. It's just not possible. If you do a REST call, and the same basically by sending a message and waiting for the response. If you do the call, you have a network problem, you have no idea if it reached your service provider, if it reached the service provider, it blew up while processing it, or if the response got lost. You have no idea. You cannot know that. And that's a problem. I mean, that means whenever I hit that charged credit card, even if it produced a failure, it might have done it. If you just raise a payment fail, that's probably, again, not a behavior your customer is so happy about. I mean, that was a payment. I might have processed it. So you have to take care of these kind of things. So, for example, you have to issue a refund, or even if that was maybe not processed, or there are a couple of strategies to do that, actually. But you have to take care of them. And again, it has to happen reliable, which normally means with persistent state. Because, I mean, if they charge my credit card and then I don't get any items shipped, for example, they cannot just give me a call and say, oh, we're sorry, we restarted the server. And then I say, oh, then I understand that it's completely clear that you didn't refund. That doesn't make any sense. So that's an important thing. And all these images, by the way, I used, it's BPMN, it's an ISO standard, that's what I meant. So it's not proprietary. It's actually not very hip at the moment if you look at these, what AWS is doing or Netflix is doing. So that's kind of weird. They're reinventing new languages, which I'm actually not a big fan of. So there are a couple of really cool things in there, and you basically saw that this is not really complex. If you're fancy BPMN, by the way, we have that lovely book. We have a couple of copies at the booth. So if you're fast, you probably grab one. Again, so we have that state machine in the service. The same thing could go for the check-in. If they would have used in the check-in like a small workflow engine, it would be great, because then they can do the retry stateful stuff themselves. Much better situation to be. If you ask yourself, okay, how do I make that part of the service? I blogged about that, so you basically can read through all of that in more detail. But just a couple of highlights for now. So what I did in the demo is basically I used Spring Boot. I started the engine as part of Spring Boot, and then I have the flow as part of the service as well. If I have a different service doing different things, that might get its own engine. No worries. Then you have the isolation, the autonomy, everything you want to have in the microservice architecture. So that works perfectly fine. We have a couple of customers doing that. If you don't use Spring Boot, but still in Java, you probably use Tomcat, Wildfly, WebSphere still around. So then it's also possible to run the engine as part of the container, do a war deployment, for example, and add the flow definition there. Then the engine is part of the infrastructure. But again, if you have different services, you might have different engines. If you're not in Java, you can also do that. Then it changes a bit. Then you probably have the engine running remote, at least in the Camunda case, but actually for most of the engines are there. And it means that within your service, you basically still have probably the flow definition, because that is owned by the service, owned by the team there, but deployed to a remote engine, and then you're talking remote, which is pretty easy. I show that in a minute as well. Okay, so there are a lot of options you can do, and I showed that in the code example before. It doesn't have to be asynchronous, just you're using like a workflow engine underneath. You still can get an HTTP 200, okay. But you should prepare for getting an HTTP 202. We cannot do it now, we send you later. Which is the same thing for me as a customer, because I actually discussed that so much last year. With, for example, my favorite example was with a train company, and they had exactly ticket booking. And they said, okay, at the end of the ticket booking, you want to have that PDF open up in your browser so you can print it. Oh, why? I have it on the app. Send it there whenever it's possible. I don't need to print it now. That's no real value in it, especially if that means if they cannot generate the PDF, I get an error and have to go through the whole booking process again. That's a weird thing. I don't want to have that. I like how Todd Montgomery and Martin Thompson, they had this slide at a GoTo conference. And this is awesome. Synchronous communication is the crystal math of distributed programming. And it goes like this. I mean, it's what we are used to. We're used to synchronous synchronous communication. It's easy. It's like I'm calling a method, I get something back. It's easy in our mind to do. And so we're tended to do that. And even if we know it's probably not the best way of doing it, just one time, then I will stop. So this is how it works. And so it's probably also good to have a look at asynchronous communication. So if we look at asynchronicity, we could do the same thing, by the way. We could have the check-in, then it maybe sends a message over to the barcode generator. And that means normally if this fails, it's not like a slow REST request, but we don't get anything back. But we more or less have a similar problem, so we have to basically monitor timeouts. And again, probably we don't want to do that in milliseconds, because whenever this guy comes up, even if it's like 1 hour later, it's okay if he sends the message. It's okay. So that's the same thing, and we want to keep that local. So we can do, we can also leverage workflow engines for that. So we could do this workflow, for example, where we say, okay, we send something to generate, and then this is the sending part. Didn't work, doesn't matter. Sending part, then we wait for something, and the wait could have like a timeout, and in this case, I do it like recurring, like every hour I resend the command. Doesn't have to be good design. I just want to visualize what I mean. And then you could even do like more sophisticated things. Yeah, and again, it's like stateful, because you basically wait for barcode, means it's persistent, and then we wait. And then we can handle time very easily, which is normally very hard to do, actually. And you could even make more sophisticated stuff, like this is already advanced BPMN. It's still the tip of the iceberg, but it's pretty cool. You could do something wherever I am, they're up there in the process. If it's like 4 hours before my flight, we want to do something else, because then the customer might get nervous. So that's very easy to do. And that's workflow automation technology. Again, in asynchronicity, it's basically adding the timeout part, but it doesn't change anything. Service providers need idempotency as well, because very often you even combine timeout with a retry. Okay, good. Talking about asynchronicity. Who uses a message bus in the architecture? Whatever it is, Rabbit, Kafka. Okay, awesome. Second question. Who has no problems operating that message bus? Oh, nobody. Normally it's one guy. So I think he even follows me on the conference. So there's normally one guy. So that's amazing, right? It's 2018. It looks perfect on a architecture diagram. I draw these all the times on a whiteboard. There's the message bus. It decouples everything. It's great. But this is reality. Nobody has no problems. Okay, no problems, probably too bold. I understand that you don't raise the hands. But what are the actual problems? What I see a lot of customers, you probably have dead messages. That means whenever you cannot have a message being received by the client, or it has an error while processing it, it throws an error. There's no sender which I can send it to, so I send it to a dead letter queue. I see these queues overflowing sometimes. That means that you lose messages which were failed. That's great. Or you look into that, you don't have any context. Why is this message there? Who did something? Who sent that? I see it very often that you cannot even look into the payload of that. So what's the data attached? Why is that data? Where does it come from? How do I fix that? How can I change the payload and redeliver the message? That's really hard problems. And I see a lot of companies putting a lot of effort in building tooling for that. And the message hospital, I heard the term actually a couple of times, and I was pretty happy to read it in Sam Newman's book as well. So it seems to be like the thing what people are building, message hospital. So there's a lot of complexity with operating that. And that's actually a pity, but hopefully that will resolve, but I don't see anything on the near-term future there. So that's the opposite part of messaging, so you still have to be aware of these kind of problems. There's one thing a couple of customers are doing which is kind of interesting. So we have that workflow engine, and what we normally do is the workflow engine, what I just did in the example, is calling actively a second REST service, for example. Right? It does that actively. It's kind of a push approach. Or if we do messaging, which I also have an example, let's see if we have time, where I send a message, for example, to Kafka, to MQP, to whatever it is. So I'm pushing, I'm doing that actively. what you can do with these kind of engines also to reverse the communication direction. So you ask for work. In the REST case, it could be that you have like a worker, client, some service, calling the REST API of the workflow engine and say, hey, do you have anything to do for me? And then you reverse the whole communication. And that's actually interesting. And with that in mind, what a couple of customers are doing, and actually a reasonable amount of them, is they don't even introduce a messaging system, but use the workflow engine as kind of a work distribution. And say, okay, we have that service that probably owns the workflow definition, deploys it, but then we have a couple of workers or services which basically fetch the work from there. And the awesome thing is that in the workflow engine, you have this kind of context. You have the operating tool. You know why something is stuck and why it failed. So that's kind of it's a very interesting option, actually. I would never put it on like, this is the architecture I propose. I know about all these discussions about smartness in the infrastructure. That's kind of a smartness in the infrastructure. So I wouldn't propose it, but I know that a lot of customers are doing it very, very successfully. Back to that, actually my favorite topic, distributed transactions. So you remember distributed systems. What doesn't really work in distributed systems is ACID transactions. So these kind of really, probably all of you are now more or less aware of that. If not, I always recommend this paper from Pat Helland. It's a great paper, Life Beyond Distributed Transactions. He explains it very well, why it simply doesn't scale, basically. These kind of two-phase commit, XA transactions, they're not really scale to bigger distributed systems. My personal favorite story for why not using it, there's a great article on Stack Overflow, and there's somebody asked, hey, I have this JBoss application server, it was JBoss at that time, and every time I start it up, I get these warnings in the log from the Arjuna transaction manager. What's that? And then the answer is, and that's really awesome, yeah, that's no problem, I know this, go to this directory and delete all the files. And then he commented on that along the lines like, yeah, great, that worked. Yeah, what he deleted were all the failed aborted transactions from the XA transaction manager, because there are situations where he cannot resolve it automatically, so an operator has to do something about it. Nobody understands that. I never met any operator in any customer, and I've been around a lot recently, who really understands that. So don't use two-phase commit. I can really not recommend it at the moment. And the requirement doesn't go away, and that's the interesting part to look at. So we still have the requirement of doing like 3 activities in an all or nothing semantics, either all or nothing. And you cannot use two-phase commit, so what to do? And what the world is currently using, it's also known as the Saga pattern. Anyone knows the Saga pattern? It gets more known recently. But in BPMN, it's called the compensation. So what you can do is, and I added something to the credit card handling where I say, first I check if the customer has credit. If he has, then I deduct it. And the next thing is I charge the credit card. And if this doesn't work, I mean, you have probably to give him his credit back if the payment has failed, right? And this is how you can do it in BPMN. And that means I raise the compensation, so throw it basically. And then all the activities which have this kind of compensation activity configured, then the compensation activities are executed. And the engine takes care of that independently of how complex the flow is. And that's pretty awesome. And again, this works reliably. Even if during compensation the customer credit service is not available, no problem. I mean, then it does it whenever it can do it. So you can stick together these different things. And that's also, I mean, yeah, it's eventually consistent, sure. You might have intermediate steps where my credit is gone and I don't have anything yet. I know that from Airbnb as a customer. When I have an Airbnb voucher code, I enter that, and then the other guy has to confirm my visit somewhere. During that time frame, my code is gone, but I don't have like somewhere to live yet. So that's pretty much it. You just have to make sure it's done at the very, very end. So that can be handled pretty well. Let's look at that quickly in real life. So what I can do, I can version 6. We skipped a version, but that doesn't matter. So I can start version 6. I think my service is still slow. Let's bring that back to normal first. So it's normal. We should still get a 202 accepted. Why is this? Let's have a look. So what I can do again, I can go to the operating tool. And that's what I mean. That's what you normally miss with messaging systems. Why is it stuck? Why don't I get a response? Hard to get. So I see these are waiting for deducting the customer credit. Why is that? Because I haven't started that. And I wanted to show that very briefly. So in this case, I don't do push. I don't call a REST service actively to do that. But I have a small component here, which is a small worker. I did it actually in JavaScript just to have one additional language. It uses the REST API. It fetches the task, then it does whatever it does, and it calls a complete method, more or less like that. Don't want to go into JavaScript code now, unless somebody forces me to. No, I hope not. So I can start that worker. No. Oh yeah, no, that was actually correct. So I start the worker. It processed these two instances. So if I go back to my cockpit, they're basically gone. Yes, I could see them in the history. So what the engine also writes a lot of data in the history. So I see what's actually going on there. Let's start a couple of them. So now I get back, by the way, a 200 OK, very fast. So it doesn't have to be slow. Just I have all these kind of things. And I run Kafka in the background for the next demo. So there are a lot of things going on at the moment. So let's do a couple of them. And there was actually, I was too fast. Yeah, sometimes there's a 500 because I say the payment fails. So I want to simulate different failure scenarios. And I run a couple of them. And what you can see is actually, if I go back, is that they are processed. So the numbers are the numbers which were processed. So I have processed 9 successfully. 2 were failed. These were the 500. And for these 2, also the compensation was executed successfully. And you could even look into details if you want to. So I can go to one of the failed instances. Then you see the timing, which is not that interesting in the moment because it's too fast. And so on, so on, so on. So you can do a lot of stuff out there. Just to not forget about one bragging feature we always show is like that heat map. So, but it transports the idea that you have a lot of statistical information about that. So you have a lot of history and audit information in these kind of tools, which is pretty awesome actually to leverage. So let's quickly move on. So then now we added something like we want to have that compensation. The very important thing, and that's actually the showstopper for most of the things, is that you also have to have a service provider which provides the compensation. And that's very often. And compensation doesn't mean it cancels it. It can be like a semantically undo. You charge the credit card, you refund it. I probably see that on my bill, but that's okay. The end result is okay. If I send an email, I probably send an apologize email. That's also okay. It's semantically undo. But you have to have it. It's not always there. And then you can tackle these kind of challenges pretty nicely, actually. There are more challenges, I know. I just picked these 3, actually. Don't forget about the state. That's where the workflow engine comes in pretty handy. And yeah, there's actually a lot of proof that this worked. And I like this quote, actually, from Jimmy Floyd in the US. They do 24-hour fitness. Who knows what a gym is? That's the really question. So, and they're doing gyms all over the US. And they're doing a lot. So what you can see there is 20 million of whatever instances. And they have even expressed something which is also important. These graphical pictures I showed you express long-running behavior in a readable format. And that's really awesome. That's what they experienced. So they said before that it was always buried in code somewhere. It might be because we have some event flows going on which we don't understand. It might be that we coded it hard. So that's pretty important. I have a second example, which we don't have really time to go into that, but so far I used mostly synchronous request response or asynchronous request response, but still request response. If you fancy going event-driven, which is quite hip at the moment as well, is anybody doing event-driven architectures? Yeah, some of you. So if you fancy that more, you might approach me later on because I don't have much time to go into that. I have the same example where I still use the payment. And this still uses upstream REST because I don't have a choice, third-party provider. But I have other services to form like the whole order fulfillment thing, with a couple of services, and I connect them via Kafka using Spring Boot and Spring Cloud Streams. It's very little code. actually, and it looks more or less the same. It's not that that interesting probably, but what you can see is, and what I did, I created an awesome UI to place an order. That's my UI. It's an Amazon Dash button though, that was the idea. So I can place an order, and then you see all the events flowing. You see that comes from checkout, and then the first thing that happens is somebody wants to have payment. That's a message, a command to the payment service, and then the payment service at some point in time says, okay, we received the payment, and then it moves on. And in the background, there's in the order service, again, like a workflow engine embedded. And in the payment, we already talked a lot about the payment. In the payment service, you also have like a workflow engine. And that's, I want to emphasize this once more. I already had it actually. That means you probably have multiple workflow engines within the different services. That's a very important thought to make it work in a microservice environment. It's not like something central you just deploy there. It's something which is an implementation detail of the microservice, of the service, because you want to have the stateful behavior there. So that's a very important thought. For the event-driven, it's actually quite awesome. Zalando is down there, but not the right people to ask these kind of questions. But Zalando is a customer, and Zalando is handling all order fulfillment over our platform. And they did a meetup last year in Berlin where they talked a bit about that. And if you look into the details, it looks very much like what I had on the last slide. They are using Kafka, they are using event-driven stuff, they are using Camuna as the orchestration layer for these kind of things embedded in these services. So that's actually very much what they do, and they do that for every order, and they are quite happy with that architecture. And they run, for example, in Q2 last year, they run more than 22 million of orders. So that's, again, it also works quite at a scale. So as a summary, don't want to go into this summary too much because you probably have listened, I hope. So be aware of the complexity. No strategies to handle it. That's a big thing. And I scratched the surface, very opinionated, only for that stateful things, basically, because they are forgotten so often. So you probably want to have stateful retry. You probably have waiting, timeouts, and all these kind of things. If you have these kind of things, or compensation, distributed transactions, that's the most awesome topic. Anyhow, you probably want to look at BPMN and these lightweight engines, for example, Camuna. So that's basically it. That's more or less all I have. If you have any questions, so we don't have time now, we have, I'm here till 2 p.m. So it's best to catch me before 2 p.m. I will be down at our booth in the 3rd floor. Any questions, just approach me. Otherwise, send me an email, send me a tweet. You find also the resources online. The slides are already online. Yeah, thanks for coming.